Welcome to this introductory series of training videos for SolidCAM. This video's topic is Turbo HSM. So the Turbo HSM toolpath is a next step above the original HSM toolpath that we've covered in this introductory series. It also will allow you to add a set of rules to finish your 3D model. But with this toolpath in particular, you have an extra set of operations, an extra set of parameters you can plug in to further dial in this finishing toolpath. So let's take a look at it. So to get to the Turbo HSM, you can right-click on any toolpath to insert a milling operation, and then you can click on Turbo 3D HSM to add that Turbo HSM immediately after whatever you right-clicked on. Now in this case, Turbo HSM, very similar to what we saw with HSM, has many technologies. So we're going to go through each one here. Let me just open up the first one, and that is Constant Z. So the Constant Z version of Turbo HSM is going to focus only on the tapered walls, the curved faces, anything that's purely vertical. It will ignore the flat faces. So we're going to go through each of the technologies in this window, but in doing so, we'll go over the general parameters of the toolpath itself. So let's take a look at the general parameters to start. So for the Turbo HSM, it being a 3D model recognition style toolpath, you can see that the geometry is set to target. Now, even though it says machining surfaces, it will machine the surfaces of the 3D model listed here. And the reason we have it defaulted to target is because the target was already defined when you first open up the CAM part. So if you're looking for a solid to finish, it's easy enough to just pre-select the target. Now, that being said, there is a new geometry button here, so you could click on other solids on screen. You can click on other surfaces on screen. It just defaults to the target because generally that's what you're looking to finish. To see how the target was defined, I'll refer you back to the new milling CAM part setup video in this introductory series. Now, 3D Turbo HSM is a finishing toolpath. So you can see that the global offset is set to 0. We could also set this to a radial and an axial offset, giving us a wall and floor offset to 0 as well. If you would like to semi-finish with this toolpath, you can always just change this value to anything above 0, and it will leave that material behind, but still do a finishing style toolpath. Just in this case, it'll do semi-finishing. If we go to Tool and then Select, it'll bring us to our tool kit, and you can see the allowable tools for use in this operation. But I'm already just selecting my tool 6, which is a 1/4-inch bull end mill. For more on how to create milling tools in the toolkit, I refer you to the Creating Milling Tools video in this introductory series. Turbo HSM also has feed control zones, so I can actually define feed control zones using surfaces and sketches. If I go to levels, this being a finishing toolpath, it really just gives us a clearance height that we can retract to, and that's going to be in the Z direction. Constraint boundaries. This is a similar window to what we saw in the HSR, the Turbo HSR, and the HSM operations. So I'll refer you to those videos in particular to see exactly how this section works, or you can also take a look at the playlist on our YouTube channel called HSM Boundary Type, and that's a playlist that goes through each of the options in the created automatic and created manually. The passive section is where you're going to see the specifics of this particular technology. So in this case, we're looking at Constant Z. So Constant Z, we're telling it how we'd like to step down in the Z direction. So step down along those tapered walls, those curved faces, anything that's purely vertical. It will not do this step down on a flat face because this is a step down in the Z direction. That being said, Turbo HSM actually has the ability here to do a step over on shallow areas. Shallow areas could be anything that has less of a taper than the tolerances on these walls, or it could be those completely flat areas. If we take a look at the wireframe of this toolpath, we'll actually see that I'm doing that 50th step down on these walls, and I'm doing that 1/8 of an inch step over on the flat areas. So this one toolpath can do all the different options here with different step overs depending on different areas of the part. Under sorting, we can tell it to do a cutting method of either one-way, zigzag, or spiral. If I choose something like one-way or spiral, I get direction of machining, in this case, climb versus conventional. Since I'm going to be going around the part, there's a lot of jumping around there. If I want to kind of localize the movement of the tool, I can use link by regions, which will take a look at the movements of the tool and actually just trim the tool path so it stays in certain areas to minimize that retraction. But if I'm looking to have some nice smooth lines, continuous lines across the part, regardless of the regions, I can switch this back to levels, and you see that the tool path continues across the gaps there. But regions is probably a cleaner one, so I'll leave that turned on. The right side of the screen and the other tabs here are just further to limit the travel of the tool and to refine the toolpath in terms of the data that we're plugging in there. So for instance, under limits, Right now it's set to automatic. It's actually looking at the top and the bottom of what I've assigned as my geometry, in this case, the target. So it automatically is just finding the z-top and the z-bottom for me. But I can always change this to user-defined and then define my limits either by the stock or the target, or actually take manual control by clicking on these buttons and choosing something that represents the z-top and the z-bottom. But again, automatic is what I want, so I'll leave that turned on. If I don't want the constant Z toolpath to be added to certain ranges, certain heights, or certain tapers, I can turn on angle range. You can see that I can filter the results depending on the angle of the wall. So maybe I'm looking to use one of the other technologies we'll cover to handle maybe a little more of these curved areas rather than just these almost vertical areas. So I can set the angle range to something that would be appropriate for those particular surfaces, and when it analyzes the solid, it'll only apply this technology, these set of rules, to those particular surfaces. Going along the lines of refining the data that we're plugging into this operation, you can see that we have cut tolerance. This is actually referring to the surface quality of the part file. So this might be a translated file where we've translated from an IGES file or a step file, and the surfaces that were translated from that solid weren't very good. They may have some error in them, and if we were to really keep a tight tolerance to those geometries, we might be machining those errors into our part. So you can actually modify this tolerance so that it actually doesn't take that close of a look, that accurate of a look at your surfaces. Under smoothing and point distribution, it's the same idea. You're regulating those parameters to get a finer look or a coarser look at your part file. In the link section, we're just controlling what the toolpath will do if it encounters a short link between the movements or a long link between the movements. And you can see that if there's a long link, we can tell it to use a lead in, lead out. And we actually have two ways to define a lead in, lead out. If we click on these three dots here, we can either use what we define as the default, or we can uncheck this box and call out specific ones to be used in the case of a long link. But that default that we call out is actually defined in this indented area that says default lead in, lead out. And again, we have those options there for those three-dimensional lead-ins and lead-outs. Under gouge check, this gives us the ability to further refine the toolpath to avoid gouges. So even though in the geometry section we actually are selecting the target, we're automatically looking to make sure we don't gouge that target. There might be other items on screen that we want to make sure that we don't gouge against. So this section is actually identical to what you see in the Turbo HSR or the HSS toolpath. So for more detail on how this window works, I'll refer you to those particular videos in this introductory series. And then lastly is transformation. So all of these technologies we'll find in Turbo HSM are all very sophisticated 3D toolpaths. So the transformations of them, either rotating around a center area or translating along different directions or even mirroring it, should be done in this operation window here, only because that heavy calculation of trying to figure out how to translate them, how to rotate them, is best done in this window. So that is constant Z. We can take a look at the next operation, constant Z rest machining. So what constant Z rest machining, rest finish is going to do is essentially just repeat the constant Z toolpath, but with a smaller diameter tool. So in my tool section, I've actually selected a 1/8 of an inch ball end mill. In the reference tool section, I'm telling it that the previous tool I used was my tool 6, which was a 1/4 inch bull end mill with a certain corner rad. The passes have similar controls here. You can see I have step down and shallow areas, angle ranges. Pretty much everything this is the same here. The reason being is I'm going to apply the same rules to the part, but this time I'm going to pay attention, or I'm allowing the software to pay attention to see what the previous tool did and what this tool can take over and do. So those are constant Z toolpaths, but applied to the areas that could not be done by that previous tool. The next major technology is Turbo Hsm Linear. So with the linear toolpath, again, all the general parameters are the same, except in the passes section, we'll see some details that are specific to the linear movement of the tool. So in this case, we have a step over along the entire part. So I'm asking this 1/4 of an inch bull end mill to do a 1/8 of an inch step over along the part, wherever it is. But as it gets along the part, if there are certain portions that could be better served by a little more of an adaptive step over, I can check this box here, and you'll see that it actually will morph the toolpath just slightly to make sure it better finishes the surface. Again, under sorting, we have one way or zigzag, and as soon as I choose one way, it would unlock the direction of machining. This being a linear toolpath, it actually needs to know which direction to zigzag back and forth across the part. And that is the define angle by, and right now, by default, I have the box checked for optimal machining angle. This will take a look at our model and figure out where the best passes back and forth across the part will be. Generally, it is the longest passes, the least amount of movement to get the longest passes around the part. But if you wanted to, you could uncheck this box and tell it what angle off the x-axis you'd like to travel, or you can you can define a line by 2 points, and it will determine the angle that you ask it to travel. If we exit out of here and take a look at the wireframe, we'll see that it's zigzagging back and forth in that x direction. Next on the list is Turbo HSM constant step over. So constant step over is essentially just going to do a step over from the outside edges of the part. If we take a look at our passes section, we can see that we have a maximum step over here of 1/8 of an inch. And if there are any portions of this model that are a little steep, in this case, this is a step over. It goes in both the flat and the vertical areas, but there might be some areas that are just too vertical for a proper step over like this one here. So actually, you can tell it that on the steep areas to do a different step over. If I check the box there, we can see that on certain areas, I'm doing a step over of the 1/8 of an inch, but as it gets to portions where we need to go a little steeper, you can see that I'm getting that 40 thou step over on those vertical walls, or those nearly vertical walls. And again, under sorting, cutting method, one way, zigzag or spiral, cut order, you can tell it which direction you like to cut. So standard would be just one side to the other, center away, outside to center, top to bottom, bottom to top. So you have the ability there to give it different directions to move along the part. Now with that, there might be some sections that even though I'm giving it some steep step overs, I need to address it with a smaller tool. So again, this one actually has a constant step over rest option as well. And this one works similar to what we saw with the previous rest. We'll choose our smaller diameter tool. Again, I'm choosing my 1/8 ball end mill. Reference tool is that same reference tool. And then when we get to the passes section, I'm giving it a different step over, a different steep step over. And then it's going to just machine or finish what the previous tool could not do. In this case, just those tinier areas there. Now, using the rest option here is really just doing what the previous one could not do. But if I'm looking to actually detail those really tight areas, there is a pencil option in the Turbo HSM operation. So let's take a look at that now. So you'll see in the passes section, we have the option here of turning on multi-pencil. So if you don't have this option turned on, you won't be adding a step over to your toolpath. You'll just take your tool and then just pencil mill in the tight areas that this tool is able to do. But if you want to have a little bit of a step over, I have one that's kind of exaggerated here, but you can see that in the pencil areas, the tight areas, I'm actually doing a little bit of a feathering out with 5 passes of 50 thou. And again, this is a little overkill for this particular part file, but for the video, you can see that it's actually stepping over in those tight areas. Okay. Last on my pre-programmed list is Turbo Hsm Horizontal. So this one is essentially the opposite of the Constancy. This is going to focus on only the flat areas of this part. So of the entire solid, I can tell it to focus on just doing the flat areas, adding an 1/8 of an inch step over on those flat areas. Since we're doing flat areas almost like a pocketing style toolpath, we have the same options of contour and hatch. Under sorting, we have cutting method, one way or zigzag, direction of machining, climb, and conventional. On the right side here, there's an additional parameter here for the further refinement of the horizontal toolpath, and you can see that it is the minimum width. So if that flat area is just small enough that it really should not be we shouldn't bother doing it with the horizontal, then we can get it to ignore that using that. And the same with the maximum width as well. There might be certain areas that we're not going to do it this way, we might do a different toolpath completely. So we can actually add that little bit of a filter there. Now, all of those options are the main ones in this list, but there's also the bottom one here where you can combine your constant Z with the linear option or combine the constant Z with the constant step over. The idea here is using that angle range, you might want to do constant Z with a certain set of surfaces at an angle, and then you can do these other ones for other portions of the solid that are different angles completely. Maybe the flat areas or the very shallow areas would be better addressed with technologies found in these options rather than just the constant Z with just the shallow areas option. So Turbo HSM Gives you the ability to add a set of rules to further finish your large part. And this one actually allows you to choose the solid rather than individual surfaces, although you do have the option of choosing individual surfaces. But the benefit of using the 3D model option is that I don't have to go in here and zoom in and click on the tiny little surfaces here. I can just get it to look at the entire solid for me. Any questions of this or anything else from SolidCAM, just give us a call at 1-866-975-1115, extension 2, and stay tuned for the rest of the videos in this introductory series. Thanks for watching.